Hello, algebra students. How you doing today? Okay, so today we're moving on to literal equations. So, what is a literal equation? Well, literal equation is just when we are working with algebra, but we don't have any numbers necessarily. We might have one or two, but there's not nearly enough to solve the problem. So you look at this problem here, and it says solve blah 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 for x. Now, if I didn't have A, B, and C, and instead of A, B, and C, I had numbers, this would be very, 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 very easy. Let's imagine that A was 1x minus, and B was, let's say, 2x, and equals C, which was, I don't know, 13. Okay, I'm just making numbers up. We combine like terms, you get negative 1x equals 13. Then you divide both sides by negative 1 to get rid of that negative, and x would equal negative 13. Job done. That was so easy. You'd be like, that's what, 2 steps? Wow. Pretty easy. But what is not that way? That's not going to work. Okay? So, basically, when you're doing a literal equation, what you got to do is you got to say, well, I'm kind of doing the algebra for somewhere in the future. Okay? Now, if they gave me numbers like here, it'd be easy to solve, but they're not giving you numbers. Maybe sometime in the future, someone is going to give me what A, B, and C is, which is exactly what we're doing. We're saying, in the future, when I find out these numbers, when someone presents me with A, B, and C, I'll be able to fix it, but I want to make it easier for myself because I want to solve for X. And of course, if we remember, when we say solve for X, we mean that at the end, it'll be X equals. Okay, so let's look at our problem here. Ax minus bx equals c. Now, I know I can't add a and b, and I can't do anything with c. They can't do anything because, one, I don't have any numbers here. So this is what I'm going to do. I'm going to look at this first, and I can say, well, over here what I did was I combined like terms. I said 1 minus 2. Well, that makes sense. So this is really 1 minus 2 times x. So this is a minus b is what it's eventually going to become times x. That's the same thing as this. Equals c. Now whatever this number is, when I eventually give someone a value for a and b, let's say it is, 4 and 3. Then it'll make more sense. Then it'll become 4 minus 3 is 1, and you divide both sides by 1, or 4 minus 2 become 2, and you divide both sides by 2. Then it would be easy. But what we got to do is remember we got to do the same things here. So this number, a minus b, is just a number. So I got to divide both sides by this number, a minus b. I can't say what a minus b is numerically, or with numbers is what I'm saying, but I can say is that when you do give me the numbers, I'll know exactly what to do with it. So that's what I'm doing. I'm kind of pretending in the future I will get these numbers. Now, a minus b divided by a minus b is just 1. I will get x equals c over a minus b. Now, if you think about this, this is where we come with formulas in science all the time with. When we say something like this, what we're saying is, I could figure out this particular thing. This being maybe the distance between stars or something like that. If you give me these 3 other numbers. And someone will eventually come along and give you A, B, and C. And it says here, I'll take C, and I'll divide it by A minus B. And that will give me x. So you're kind of working towards a future when you get those numbers, but you're making it easier for yourself now. So when the time comes and when someone gives you A, B, and C, you will already have the formula for it. You won't have to do any algebra. Okay, guys. I'll be back in a minute. Good job.